Welcome once again to Master Science Guide. Now, we are still on the series of organic chemistry. Now, in order for you to properly understand chemistry, there are two things you must understand: alkyl and acyl groups. What are alkyl groups and what are acyl groups? Now, look at this. An alkyl group, an alkyl group is represented using arrow. All right, an alkyl group is represented using what? Capital letter arrow. Now, alkyl groups, generally, alkyl groups have the general formula of CnH2n plus 1. So, once we are talking about alkyl group, one thing you need to understand is that alkyl groups have what? The formula of CnH2n plus 1. So that simply means anywhere you see CnH2n plus 1, it implies what? Alkyl group, which is also referred to as what? The arrow group. Are you with me? Or basically, you can simply say that alkyl groups are formed, okay? Alkyl groups are formed when alkanes loses one hydrogen. So when you remove one hydrogen from an alkane, what do you get? You get the corresponding alkyl. So if you take, for example, methane, CH4, if you remove one hydrogen from methane, what do you get? CH3. So this is known as what? A methyl. If you remove one hydrogen from ethane, what do you get? C2H, remove one hydrogen, get what? 5. This is known as what? Ethyl. So you are seeing we are getting the corresponding what? Alkyl. Then if you use propane, C3H8, if you remove one hydrogen, from propane, what do you have? C3H7. So this is known as what? Propyl. So you can just do it like that continuously for all the alkanes. So if you go to butane, C4H10, remove one hydrogen from the 10, what do you get? C4H9. This is known as what? Butyl. Are you getting it? So please take note. So two things you have to watch out for. Whenever you see CnH2n plus 1, just know it refers to what? Alkyl. Alright? And you can also derive your alkyl by removing one hydrogen from an alkane. So think of any member of the alkane, remove one hydrogen, you get your corresponding word, alkyl. So just like this illustration here. So please take note. Now, if you look at my previous video on homologous series and functional group, where I gave a table of different homologous series, their general formula and their functional group. Take for example the alkanol. All right, the alkanol. Now, alkanol has a general formula of what? CnH2n plus 1 OH. So now we can simply replace this CnH2n plus 1. We can replace it because why? How? Now remember I told you that alkyl group are CnH2n plus 1. So we can easily replace this CnH2n plus 1 with what? Arrow. And then we can also have what? Arrow OH. So this still the same as this. Now, if you think of any other homologous series, let's take the esters for example. Now the esters general formula is CnH2n plus 1 COOCnH2n plus 1. So by the time you do this alkyl, so by the time you replace these guys with arrow, what do you have for the esters? You have what? Arrow COO arrow. So this idea can be applied to any of the family in any of those homologous series family. All right, whenever you just see CnH2n plus 1, just replace it, remove that CnH2n plus 1 and put arrow there. You get your corresponding what now? Your alkyl, which is the arrow, and then you have the corresponding word functional group alongside. So like this guy, the functional group is OH, then the alkyl group is CN plus 1. So I can rewrite it, replace this for the sake of not so that it does not look ambiguous, all right, does not look too something big and complex. So you can reduce this to just R O H. So that is the essence of understanding this alkyl group. Now, alkyl group is also very important in the sense that when you want to name compounds and then when you want to understand reactions, all right, you also need the knowledge of this alkyl group. So I advise you to pause this video and or you can take it back and rewatch in case you miss any detail so that you grab it. Next, now let's talk about the acyl group. So we have been able to go through the alkyl group. Now let us talk about the acyl group. Acyl group. All right. So now the word acyl is two things put together. Acyl is alkyl and carbonyl. Are you with me? Acyl is alkyl and what? Carbonyl. So this is what you have as what? Your acyl, alkyl and carbonyl. So it means that acyl has what? Alkyl group RO and then a carbonyl group. Now what is a carbonyl group? A carbonyl group is carbon doubly bonded to oxygen. That's a carbonyl group, all right? Carbon doubly bonded to oxygen, or you can simplify it and just write it as CO. Carbon doubly bonded to oxygen. So understanding this alkyl and carbonyl CO. So to write the formula of acyl, acyl will now be represented as what? ROCO. This is acyl. ROCO is acyl. So anywhere you see carbonyl, just know you are talking about carbon doubly bonded to what? Oxygen. That is CO. And anytime you see CO, just know that that is what? A carbonyl group. Are we together? So if you look at the alkyl acid, for example, alkyl acids, looking at the functional group, the functional group is what? COOH. Now, when you open this structure, you get C double bond O and then OH. So that means the carboxylic group, all right, the carboxylic group of alkyl acid, this is what you call the carboxylic group. Okay, so the carboxylic group, which is this guy of the alkyl acid, literally has two groups. Okay, so it has a carbonyl group and what? An hydroxyl group. So please take note. C double bond O implies what? Carbonyl. Are we together? So in summary, we can write the formula. Okay, this is already the formula. Okay, or you can simply replace. Remember I said that arrow is what? CnH2n plus 1. So you can do it like this. CnH2n plus 1 CO is acyl carbonyl. Acyl carbonyl is what we have. So if you look at esters, general formula ROCOO. Now, basically the functional group of the ester is this main guy here. All right, that's the functional group. That's COO. So when you open this, you have C doubly bonded to oxygen and C singly bonded to another oxygen. But then the oxygen is also carrying this arrow. So you can just add this arrow here. So have it like this. All right. Or I can decide to put a bond here and put it like this. So that simply means now that the ester group, right, the ester functional group, the functional group of esters has a carbonyl group and what? It has an ether. This is what you call the ether linkage. It has the ether linkage. Alright, so it has carbonyl and then it has what? Ether linkage. If you also look at the aldehydes, general formula ROCHO. Alright, what it implies, this guy is the arrow, then C doubly bonded to oxygen and then H. So you see, we still have the carbonyl alongside here. So this is what we mean by acyl. All right, alkyl carbonyl. That is what it means. So when we now enter into reactions, you'll now be seeing some reactions. It will tell you this has to react with a compound that contains an acyl group, stuff like that, and then it becomes easy. Now this is the last foundational aspect we're going to treat. From henceforth, we're going to be focusing on reactions. So please do well to watch my 2 previous videos on this, on organic chemistry, so that you can follow up and understand reactions by the time we get into reactions. Thank you for watching this video, and I'll see you in the next episode. Thank you.